Our cities are changing. They're becoming smarter, more connected and more automated. And they're getting ready for a new revolution, led by robotics.
Robotic technologies are entering our urban spaces.
In future, we will have affordable robots such as Robi in our households to help us save time and to spend more time with our family.
The house of the future will definitely adapt itself to your needs.
The evolution of our urban environments is in the hands of robots. Let's examine the most exciting European technologies that are set to change the shape of our cities. By the year 2050, 3/4 of humanity will live in urban areas. And in this century alone, we will witness more technological advancements than in the last 500 years. These two trends will combine to create significant changes in our daily lives and in the urban spaces we inhabit. Robots will play a crucial role in all this, and by looking at robotic systems that are being developed worldwide with a commanding influence from Europe, we can take a glimpse at the city of the future. The flying cars that science fiction predicted are not yet upon us, and perhaps they never will be. But the future of our cities is already here, driven by a number of technologies that are becoming ingrained in our lifestyle.
A lot of these technologies, think about network sensors, robotic technologies, are now entering the space of the city. And they're changing many aspects of our lives. That's what most people today refer to as smart cities.
I think the age of robots will dawn gradually. To some extent, it has already started to happen. In manufacturing, of course, there are robots that help put together cars and other machinery. They are out of view, so we don't really think of them because we don't see them. But still, they are there, and they are an increasingly important part of the economy. There are devices in our homes that are kind of robots, although we don't think of them like that, like your washing machine. It's a physical object that has actuators and performs certain movements to achieve a particular purpose. We don't see it as a robot because it doesn't have human arms and legs, it doesn't move around. Maybe the first mass consumer robot that will move around will be the self-driving car, where great strides have been made over the last few years. And once that gets acceptance, it could really have a huge market because cars is such a large part of the economy that if you could automate that, it could really make a big dent in the economy.
The robotic revolution starts from our city streets. Self-driving cars are already an established reality, with several ongoing research projects around the world. This one comes from Italy, where the team at Parma's VisLab has recently achieved extraordinary results.
This has been the first time for an autonomous vehicle to face real urban traffic. And it has been quite a tricky environment, since it has been done on Italian roads that are narrow with heavy traffic, facing things like a roundabout, for example.
Similar to Brave, the Robot Car UK project, developed at the University of Oxford, is based around low-priced sensor components. The entire autonomous navigation system fitted on this electric car costs less than €7,000. And researchers believe that in about 15 years, when this technology will have become widespread on public roads, the overall cost will have dwindled dramatically, down to about €150. When it's on the road, the car constantly scans the environment and uses a dynamic learning algorithm to acquire information on where it is and where it's going. Obstacles, especially moving ones, are monitored 13 times a second with a frontal viewing angle of 85 degrees. Inside the car, the navigation interface is provided by an iPad, and whoever is sitting in the driver's seat can take control at any time, simply by touching the brake pedal. A more radical and futuristic approach comes from the German Center for Artificial Intelligence in Bremen. Its smart electric vehicle prototype is called EO, which means I go in Latin. And while it's still more of a research platform than an actual product, a fully functional model has already been built. It weighs 600 kilograms, is powered by 4 electric motors, and is 2.3 meters in length. And in the future, the prototype will be fitted with advanced sensors that will allow for potentially groundbreaking functionality. The goal is to have fully autonomous vehicles that can move freely through traffic without any risk of collision, and with the ability to interact with similar vehicles. AO cars could, for example, form a convoy on the highway, saving fuel and increasing safety. When needed, a single car can detach from the convoy and take an exit, or a new one can join in. And battery charge can be shared among the cars to supply energy where it's most needed. Interestingly, this project is based on a range of technologies that are all commercially available. Here at Bremen, they've been united into a single system with its own specifically designed software. It's only natural to worry that these vehicles might be in some way dangerous for their passengers or for others. But the available data would suggest otherwise. Google has been testing its own self-driving cars for years now and have racked up nearly 1 million kilometers without directly causing a single accident. Only 2 have occurred, both as a result of human error. So, these vehicles are statistically safer than those with a human in the driver's seat. According to various estimates, the large-scale distribution of autonomous cars could cut accidents by 90%, with a significant reduction in the loss of human life and consequently savings of billions. That's why almost all car manufacturers are experimenting with these systems. And the general consensus is that they will be a fixture on our roads by 2020. Before we get there, though, there are some issues to resolve that go beyond the technicalities.
Self-driving cars are a reality as we speak. There are self-driving cars all across the world being tested by companies and universities worldwide. The important thing is not too much the technology, it's actually all the ecosystem. Think about responsibility and liability. What happens if you have an accident with a self-driving car? Are you going to sue the car company? Are you going to sue the city? Not the driver, because there's no driver. So that's just one example of what is today one of the critical issues we need to tackle.
It's not just about regulations and permits. The idea that there's no longer a human mind making decisions behind the wheel forces us to move the discussion to a different level, one involving ethics.
When figuring out whether self-driving cars should be allowed on the road, we should use the same standard as we use when we decide whether a human should be allowed on the road. If they are safer than a typical human driver, then I think they belong on the road. They don't need to meet any perfection, or we don't need any proof that they couldn't cause accidents.
As well as cars, there's another class of robotic systems that might soon alter the way we live in our cities. We'll find them in our streets, but even more frequently in large public spaces. They are service robots, like Reem, developed in Barcelona by PAL Robotics.
Il Reem è un robot umanoide di servizio creato per aiutare le persone in ambienti urbani. come per esempio un centro commerciale nel quale può aiutare le persone a fare la spesa e portare anche le buste della spesa, o anche in un museo dove potrebbe essere la guida al museo presentando le diverse opere presenti. Un altro caso d'uso potrebbe essere un aeroporto nel quale il robot può essere teleguidato per dare informazione ai passeggeri, come per esempio il cambio di una porta d'imbarco o lo smarrimento di una valigia, o anche solo aiutare le persone a sapere dove ci sono i diversi servizi dell'aeroporto.
To get the information they need, users can touch the screen or speak directly to the robot, which is equipped with a speech and face recognition system. Its batteries allow it to function for up to 8 hours without recharging, and thanks to its electric motors, it moves at a speed of about 5 kilometers an hour, the equivalent of a human walk. Its height of 1.65 meters and its human likeness also help make the machine easy and pleasurable to interact with. But a service robot doesn't necessarily have to be shaped like a human. This one comes from the Swiss Federal Institute of Technology in Zurich, and it belongs to a peculiar class of robotic systems called ballbots.
Ballbot is a robot that balances and drives around on one single sphere. We designed our robot for high dynamic maneuvers and human interaction. Now, for a robot to interact with people, it needs to be at the normal level, and it needs to come around between chairs and tables and don't get stuck in normal environments. And with a robot like a ballbot, you can achieve this.
A robot that balances on a sphere has a single contact point with the ground, an inherently unstable configuration. So how does ReZero maintain its balance? It does so thanks to a sensor that monitors the inclination of the robot 160 times a second, and then counterbalances this by activating its motors in the appropriate direction. To move around, the robot uses 3 small wheels that are connected to the sphere, allowing it to move in any direction. This unusual locomotion system is not only extremely dynamic, because it allows for lightning-quick acceleration, but also very elegant. The robot glides around with the grace of a skater on ice, and ReZero's stability is never compromised, even if the machine is pushed or kicked.
We think of a robot as a service robot that interacts with people. So this robot could be used in a museum to guide people around, or in a hospital to help that the people carry the medical equipment. Also, it could be used in a restaurant for the waiter to get his dishes faster to the tables.
In Barcelona, on the campus of the Institute of Industrial Robotics and Informatics, we find Tibi and Dabo, 2 robots named after the hill that overlooks the city. They are 2 service robots that belong to the European EURUS project, which aims to create robotic systems to enhance the quality of life in urban environments. They're designed to look like a boy and a girl, and can work together with a third machine, a self-driving vehicle based on an electric golf cart. This vehicle has an autonomous navigation system and smart sensors to avoid collisions. Users can ask one of the robots for directions, then get on board the car and reach their intended destination in total safety. One potential obstacle to the widespread use of these robots comes from their cost. Most of them are currently very expensive. At the University of Delft in the Netherlands, Robbie and Leia are a couple of service robots designed precisely with this problem in mind.
Before we bring robots to real world, there is one problem that we have to solve, and that is the really high cost. So they need to be available for the consumer market, and in that case, which means that the pricing needs to be much lower. So if we take a look at the robots such as that are right now available, such as Asimo, or for example the Armar robot from KTH University, or iCab from Italian Institute of Technology, so the pricing ranges around €500,000 or €250,000. And that is too much for any health institution or for any individual right now to buy. So therefore here at the Delft Robotics Institute we would like to design robots that are very affordable and that any individual can bring to their household. We would like to lower down the pricing from 20 till almost 30 times of these robots, and to make sure that eventually they will be around the price of a single car, and that could be part of any household that individual can buy.
To keep their final cost down, The robots weren't assembled using standard industrial components, which can be very expensive, but with custom mechanical parts and circuit boards designed to be as cheap as possible. This also made it easier to incorporate the ability to interact and cooperate with each other directly into the design. At the Bristol Robotics Lab, we meet Molly, a robot designed specifically to offer assistance to the elderly in their own homes.
We have an aging population, and unfortunately, due to limited resources, there just aren't enough carers and care facilities to support people in their own homes. So technology such as companion and assistive robots can support people and empower them to look after themselves, and also support carers in helping to augment their roles. So we can leave the care of the human aspects of care to people, and the technology can augment and support and enhance what is offered by a human carer. Robots can help us to live independent lives for longer and ensure we're living rich and fulfilling lives.
Molly can be controlled with speech or with the integrated touchscreen, and doesn't only offer help for house chores or the transportation of small items, but can also function as a companion. A standard computer is connected to the touchscreen and can be used to show videos or photos, read and send emails, and connect the user to their loved ones through video communication. And all of this is a simple voice command away. An even greater challenge is building robots that can offer real comfort to an aging population. By 2050, in Europe alone, the number of people aged 65 or over is expected to rise by 27%. Robots could therefore be an interesting option for offering assistance to a constantly increasing number of individuals. But to do so, they'd probably need to have a very human characteristic: empathy.
Robots being a viable option to assist the elderly, I think, is a two-sided sword, really. On the one hand side, caring for the elderly is a very, very demanding job, especially physically and also emotionally. So I can see it absolutely making sense to employ robots, because it's a very tough and hard job. It's also not very popular. It's difficult to staff these positions, and it will get more and more difficult in the future. However, taking care of someone as a core component requires empathy. It requires an understanding of the other person. It requires, ideally of course, a social connection between the two. And I don't really see robots being capable of that. So on the one hand side, I can see the benefits. On the other side, I fear a certain dehumanization of a very human activity.
It's likely then, at least for the most delicate assignments, that robots will never be able to fully replace human beings. But then not all robots are designed with this in mind. Some of them are completely innovative and have been designed from the ground up. One rising field is domotics, which uses informatics and telematics to support activities in the home. And then, the city of the future could also be built by rethinking our everyday spaces completely, as the Hyperbody project of the University of Delft aims to do. The robot here is not moving around the house, it is the house itself. And it can change its configuration to simulate a floor space twice as large as the physical one. All it takes is a few simple commands.
In the future, imagine if you're driving in your car or you're traveling somewhere and you have a mobile app or an app that's inbuilt in your car, and you can actually program your house to actually tell that, okay, there are 2 guests coming with me, kindly customize the house in order to receive these guests, and I need an entertainment kind of a situation. And your house is able to do this. So that would be just fantastic. But at the same time, imagine another system in which, what if you travel globally? You're almost like an urban nomad. And no matter where you travel, the house which you book or which you register for even a certain amount of hours is able to fully customize itself in accordance with what suits you the best. So this can be either in the form of registries that you enter with so your name is connected with everything that you like, which is what your house actually becomes. So no matter where you travel in the world, you will always have your house anywhere and in any corner of the world.
The idea of a physical object that can change shape autonomously is also behind the Roombots, small self-assembling robots designed at the Federal Polytechnic of Lausanne in Switzerland.
Roombots is a self-reconfigurable modular robot, which means that each robot is a single module, fully autonomous, and can connect to other modules to form a bigger structure that can achieve more complex behavior.
For example, the modules can form chairs inside a conference room in the morning and then transform into tables in the afternoon. In a home environment, on the other hand, the Roombots can remain invisible until they're actually needed, taking the shape of a wall, a screen, or a box. When they are needed, they can then morph quickly into furniture of various types, such as a stool or couch. So, it turns out that robots can change the shape of our homes from the inside. But in the future, they could also help us build them, even in an environment where human-made structures do not yet exist.
Una possibile base lunare del futuro sarà costruita da un robot direttamente in loco. La tecnologia si chiama Additive Layer Manufacturing e invece di utilizzare il classico modo per costruire, vale a dire partire da un blocco e rimuovere materiale, parte da una polvere e aggiunge materiale strato per strato. Quindi, dovendolo applicare sulla Luna, il vantaggio è che si può utilizzare il suolo lunare per costruire la base utilizzando il suolo lunare stesso senza dover portare nessun materiale dalla Terra.
The way this works is not very different from that of a 3D printer. The difference is that this system does not use synthetic materials, but regolith, the sand that is naturally present on the surface of the Moon. This technology is called D-shape and was invented by Italian engineer Enrico Dini. It's already being used on Earth to build simple dome-shaped houses, using sand to create firm structures. The project to apply this to lunar bases has been commissioned by the European Space Agency. There would be no need to haul construction material from Earth, and the resulting shelters would also have another advantage. They'd be fully capable of shielding the astronauts from the most dangerous threats they would encounter while living on our natural satellite.
Sulla superficie lunare ci sono due problemi fondamentali che costituiscono una minaccia per la salute degli astronauti e per la sicurezza degli astronauti. Uno sono le radiazioni e l'altro sono le micrometeoriti. Tutti e due si possono collegare all'assenza di atmosfera sulla Luna. Con questa tecnologia possiamo risolvere entrambi i problemi perché lo spessore della struttura che abbiamo realizzato può bloccare sia le radiazioni che i micrometeoriti.
The European Space Agency has already spotted the ideal location for a base, the lunar South Pole. Meanwhile, a 2-ton prototype of the structure has been built, using volcanic rock. Applied to moon expeditions, this printing technology would open the way for truly revolutionary exploration missions, even though the project is still in the very early stages. But we don't need to look too far ahead to realize that robotic systems will play a crucial role in shaping our urban spaces. And this could mark the beginning of a new era.
In all of these machines, think about laser cutters, think about routers, think about any different type of robots. Well, you know, they're having such a profound impact on our society, on the way of producing, that some people think we're at the beginning of a third industrial revolution.
If a third industrial revolution were to happen, though, this could lead to a dramatic imbalance in the job market. According to various estimates, nearly half of our current jobs risk being taken over by robots or automated systems. Machines in production lines have already changed the manufacturing business completely. But with constant advancement in the field of artificial intelligence, robots could soon start to become a viable option even for professions that do not involve much physical work at all.
With regards to robot replacing human work, well, that is not a very new issue, is it? Technology always has replaced human work in the course of history. Has this led to more global happiness because all the machines do all the work for us? Probably no. Has it led to an enormous downfall where everybody's unemployed and homeless on the streets? Probably no. I think what we see is history repeating itself. More jobs will be taken over by robots, new jobs will come up that robots cannot take over, there will be more unemployment in some areas, more employment in others. It's all history repeating.
Robots will have a profound impact on the job market. They will make some jobs disappear and they will create other jobs. So of course that's an issue in the short term. But I think if you look at the long term, basically what they're doing is actually removing some of the jobs we're not interested in. So I would say it's a positive effect.
Whether robots will be a benefit or a problem will come down mainly to the decisions we make while designing and building them. But there's little doubt that they will play a key role in our cities of the future.